Hey guys, welcome to this session on Learn Exploratory Analysis in Python from scratch. Exploratory analysis or exploratory data analysis or EDA for short is one of the most important aspects and one of the most important steps that we take in order to get better understanding of what our data represents, what needs to be done with the data that we have, and how underrelated patterns and features relate to each other. So keeping that in mind, we've come up with this session to help you get started with exploratory data analysis in Python from scratch. We assume that you don't know anything about exploratory data analysis, so we'll begin from absolute basics. And with that in mind, let's start with the session. But before I begin, I'd like to point out that in case you wish to learn more in depth about exploratory analysis and machine learning and data science in general, stick around till the end of the session where we'll guide you through some of the resources that will help you out in order to learn these things. So let's take a look at the agenda for the session. We will begin by taking a look at what is EDA, since this is meant to be for people who have no understanding of exploratory data analysis. We'll begin completely from scratch and we'll define what exploratory data analysis is. We'll then move on to understand why EDA is performed, why exploratory data analysis is performed, what exactly does it get you. Then we'll move on to learn about exploratory data analysis with Python. We'll understand why exploratory data analysis is done with Python, why Python is so popular to do EDA. Then we'll take a look at a few advantages of EDA, as in why doing EDA what are the benefits that doing EDA on the dataset that you have available can bring to you. Then we'll take a look at some of the libraries that we use while performing exploratory data analysis. These libraries are implemented in Python. Since this is a presentation in which we'll be using Python, I'll firstly explain about each single library. We won't be covering all the libraries, just the one that are used most often. There are other libraries available as well, and you can use many libraries from the Python data science ecosystem. And then finally, we'll end it with a demo. In the demo, we have a data set and we'd like to perform exploratory data analysis and figure out some heuristics about the data that we have or the data set that we have. So you can follow along with me in the exploratory data analysis demo. And with that, we begin with our first topic, which is what is exploratory data analysis. I've shortened it all up for EDA. EDA stands for exploratory data analysis, or exploratory analysis is also something it's called. So exploratory data analysis, or EDA for short, is the process of performing initial investigations on data so as to discover patterns, abnormalities or anomalies and assumptions with the help of summary statistics and graphical representation. Basically, when we have some data on which we want to perform data science and statistical analysis and machine learning modeling, we first need to make sure that we understand what the data represents, shape of the data, what are the different kinds of things that are available in our data, different data types available in our data. If we could visualize our data and understand relationships between individual columns or individual features in our data, that's really good. And all of that and more, such as visualization and all, is done in a step called exploratory data analysis. So that's what EDA is all about. Now, EDA allows us to get a better understanding of our data and make important observations on it. In order to understand this, let's understand with an example. If you have a data set which you have no understanding of, you don't understand what the data it contains is, what do the columns represent, how do the columns relate to each other, and which columns are important for the particular task that you are trying to solve. In cases like this, it is very difficult to understand how you are going to solve the problem, how you're going to build the model, how you're going to perform statistical analysis, so on and so forth. So in this sections, what happens is we would like to perform exploratory data analysis in order to get a better understanding of our data. This also helps us understand whether or not the data that we have needs some sort of boost. So, for instance, if we have some data set that's highly biased on one result, for example, we are trying to predict whether or not a particular internship is going to convert into a job. Let's say we have a data set and we want to figure out whether or not we can create a predictive model in which we can feed in some data about an intern and figure out whether or not we should give them a job. Although it's a very specific use case, if all we have is data where people did not get converted into full-time employees, our data set is completely biased, and this is something that we could miss if we don't take time to analyze our data. using exploratory data analysis. So if that is the problem, then we would have to get more data so that we can balance out both the probabilities and then teach our model about these things so it has better understanding of what features lead to what results. So now we come to why EDA. Why would you want to perform exploratory data analysis? We've understood what it is, but why exactly would you want to do it? Well, exploratory data analysis is one of the most crucial steps in data science. It allows us to achieve certain insights and statistical measures that is essential for the data scientist. A good understanding of exploratory data analysis process allows us to make some important observations and early decisions that could help us reduce or that could help us not take steps that are not needed. So as we discussed in the previous example, if our data set is biased, then performing modeling and using multiple algorithms and trying to figure out the accuracy of each model is not going to be a good idea, mainly because the data set we have is not good. If you don't have a good data set or don't have a data set that's representative of the reality in the current world, then your model is not going to be good. It's not going to perform really well. So exploratory data analysis helps us perform as fewer steps as possible in order to get the best result. This is why exploratory data analysis is so crucial a step in our data science process. So it performs certain steps to define and refine our important features and variable selection. So it could be that you have a data set that contains 25 different columns, but for what you are trying to predict, only 3 or 4 columns are going to be enough. They explain most of the things or most of the variation in the data or in the column that you're trying to predict. So you only need to use 4 variables. Now, which 4 of those should you use, and if indeed are they 4 variables or are there 5 variables that explain it better? For that, exploratory data analysis is important. It allows us to select features that are going to be useful for us. In case we don't use the correct features, we end up with a model that's highly bloated, contains data that's irrelevant, requires users to fill in data that's relevant, and could lead to incorrect or highly improbable results. So we need to be very careful when we're trying to take model columns or columns on which we are trying to model our data on to make the predictions. Now, why would you want to perform exploratory data analysis with Python? There are many other languages out there, including R. You can even perform exploratory data analysis in JavaScript and Java and C++. So why should you use Python? Well, exploratory data analysis using Python is very easy. First of all, Python is probably one of the easiest languages to get started with. This is why Python is so popular in data science community, because many people who perform data science operations or machine learning operations on a particular data set are people who come from the academic world. They don't have much understanding of what programs are, what variables are, what classes are. They only need to write code to get the things that they want to get done be done. This is where Python comes into play. It fills the gap. So since Python is so easier to use, and another advantage that Python provides is that it has a number of libraries that allows us to perform tasks related to exploratory data analysis. In case we are performing these tasks ourselves, it's very, very important for us to make sure that the libraries we are using are trusted and used by multiple people, because if it's a library that someone has created, our confidence in it is going to be really low. For example, if it's a library to perform data visualizations, but it's a library that not a lot of people have used, then you cannot be sure that the library is going to give you accurate visualizations, and it's always going to be a bit problematic. In Python, however, there are libraries that have been used by millions of developers and academic people. What they do is they just understand the basics and then they import their data and visualize it and perform the task that they need to perform right at the step. And that's really important for our data set. So this is why Python is such a good candidate for exploratory data analysis, mainly because it's easy to understand, easy to read, it's got a really clear syntax, as well as because it's got so much good tools and libraries around exploratory data analysis and data science in general. It's just a really good experience for developers or people who are getting started with exploratory data analysis or data science, or even professionals. Now, Python has libraries to perform all kinds of tasks relating to exploratory data analysis, such as visualizations analysis, etc. Visualize the data, there are libraries available. Not just one library, but multiple. Depending on the features that you're trying to use, you can import either one of the libraries that are available. There's libraries for data analysis, libraries for numerical manipulation. There are libraries for many other different kinds of tasks, such as creating neural networks, defining the structure of a neural network, visualizing neural networks, so on and so forth. So this is why Python is so popular. Now, some of the most popular libraries to perform EDA are NumPy, Pandas, and Matplotlib. Now, since I'm assuming that many of you are beginners and you have no understanding of what these libraries are, we will cover what these libraries do in a later point in the presentation. Also, again, if you wish to learn more about these libraries and more about data science and exploratory data analysis and Python in general, stick with us till the end of the presentation and will help you will help guide you to some of the resources that can help you out there. Now let's take a look at some of the advantages that exploratory data analysis provides us. So it provides us with several benefits. First advantage is that it allows us to spot missing data. Using exploratory data analysis, we can easily find null and missing values. So in case we have a data set in which certain columns have null values or certain columns have certain proportion of the data is missing, we can remove the data, we can fill the data. Although removing the data and filling the data is not part of exploratory data analysis, spotting the missing data is definitely a part of exploratory data analysis, and it allows us to do the same. It allows us to find the underlying structure of data. So on the surface, what we can see is the number of columns, the columns that we have, and the data that we have in them. Underneath the row and columns and the tabular structure of our data, if indeed it is tabular, what we can do is we can understand what the underlying structure is. Underlying structure means what are the different data types that a particular column holds. Are they in the correct format to be processed? What is the range of data that is contained in a particular column? Do columns relate or correlate with each other in the data set? And if so, is it helpful or harmful for the task that I'm trying to perform? So on and so forth. Then there's variable importance. Exploratory data analysis helps us to figure out which variables in our dataset are the most important ones. So in that case, it helps us understand which variables have the highest influence on the thing that we're trying to predict or on the column that we're trying to predict. That way, we can just drop the rest of the columns and only use the ones that have influence on our columns above a particular threshold. And finally, data visualization. Now, we can sit and talk about data a lot, but one of the issues that exploratory data analysis solves is that when we show these statistical measurements to people, first, especially people who are not statistically literate, it's going to be really difficult for them to understand, mainly because they have to firstly scan through the data, then understand which data has higher value, which data has lower value, and then understand the implication of each of them. It's much easier to visualize this data and understand the characteristic of the data that we possess. In this scenario, exploratory data analysis is really, really helpful. It allows us to perform visualizations and explain our data in a better capacity, even to people who may not be that familiar with the data that we have, as well as the statistical analysis that we are performing. Now let's take a look at the libraries that we had discussed earlier and what in exploratory data analysis. I would just like to mention that these are the three libraries that I have picked. These are the most one or at least some of the most common libraries that are being used. Not necessarily the case that these are the only libraries that will be used, or also not necessarily the case that these are the libraries that are going to help you in a particular problem. It could be that there are better alternatives available, and to understand about the alternatives, you need to firstly look at all the options that are available. So I recommend before starting any exploratory data analysis process, take a look at the tasks that you want to perform, take a look at the libraries that are available. These libraries are the most popular ones and for good reason. So these should help you out, especially if you're a beginner. But as you become more and more advanced and more into the exploratory data analysis and data science community, you understand that there are better tools available for the one particular task that you're trying to perform, and it's better to use those tools. All right. So the first one is NumPy. NumPy, or many people call it NumPy as well. It is a numerical manipulation library. In Python, we can perform numerical manipulation using raw Python itself, but it contains a lot of the information that are not relevant for our purposes. Since Python is an object-oriented it's programming language, which it's fine if you don't understand what that is. But in case you do understand, it stores a lot of information that's not relevant. So when we try to perform complex mathematical operations, those properties about the object orientedness of the particular variable come into play, and they negatively affect the or negatively impact what negatively impact the performance. So in situations like this, NumPy is quite useful. It firstly just keeps all the relevant data. Secondly, it has a lot of functions that allow us to perform these numerical manipulations. Inbuilt functions for calculating the sine waves, the cosine waves. For fast Fourier transform is also available, and many different kinds of numerical manipulations that are difficult to implement by hand are already implemented in NumPy. So you don't have to worry about implementing these things. You just have to worry about using them when the need be. Then there's pandas. If you have done data science with Python for any period of time, pandas is a library that you must have come across. Pandas is great for data analysis, data summarization, and many other tasks relating to data. It allows us to load data in our Python program using something called data frames. Data frames is a special object or a special way of representing data in pandas, and it affords us a lot of benefits. It allows us to perform a lot of complicated tasks on our data, such as joining two data frames, filtering a data frame, manipulating data, dropping data, and a lot of different kinds of tasks that by hand are going to be very difficult. So it's a layer of abstraction over these complicated tasks, so you can perform them yourself, and it's very efficient as well. Then we come to Matplotlib. It is a visualization tool or is a visualization library, allows us to create charts and graphs and allows us to perform a lot of visualization. Many different visualization libraries such as Seaborn use Matplotlib underneath the hood. So in case you wish to become a data scientist and want to perform exploratory data analysis by visualizing the data, Matplotlib is a library that you might need. You can also use other libraries, but Matplotlib is probably the best one to start with because it's very easy. It exposes you to some of the fundamental concepts that you need to understand when you are dealing with uh, in Iron Python visualization or graphs or charts. They can help you out with that. All right, so we have reached the demo section. Now for the demo, I have already written the code so that I don't write the code and you have to then follow along and look at the errors that I make. I'll explain the code to you now. I told you that you only need to import the libraries that you need. In the current scenario, I didn't need to use any numerical manipulations because the data is already manipulated for me. Then I can use this. I'm using Pandas, Seaborn for interactive visualizations, and also Matplotlib. These are two different visualization libraries. Seaborn is great for creating summarizations of our data sets, and Matplotlib is great for visualizing individual columns. This bit of code here is telling the Jupyter notebooks. Let me just zoom in on it because it may be possible that you guys aren't able to see this. Now, in Matplotlib, it's possible to use it with multiple backends. In this scenario, we're using it with Jupyter Notebook. We're just trying to tell Matplotlib that whatever visualizations that you produce, make sure that they are optimized to be rendered inside a Jupyter Notebook. Now, many people say it's not necessary to do this step. It was necessary previously, but now it's not. But I like to keep it in just in case. Then I am importing a data set. And to give you some context, this is a data set that I have downloaded from Kaggle. You can download it yourself. I would recommend it that you do it afterwards, and you can play with it as well. This dataset and many other datasets are available on Kaggle for you to perform exploratory data analysis with. You can do it on Kaggle as well. And when you're doing it, you can, using that exploratory data analysis notebook that you have created, you can share it with people. Kaggle is a great platform for that. So you can use it for that. And now we take a look at the first 5 columns, first 5 rows of the data. Now, as you can see, the shape of the data is 5 rows in 81 columns. Now, 81 columns is probably a lot. As you can see that even our pandas library is refusing to show all of this because it knows that it's not possible for us to show everything. So we have this. Now, we take a look at the information of the data. This tells us about the data set that we have and gives us information about each column, right? So we have 1460 non-null columns, non-null data points with of type int 64 in the ID column. And you can take a look at everything. Here, as you can see, in the alley column, we only have 91 data sets. That means that majority of the data is null. We'll deal with that in a moment. As you can see, the data is quite disparate. Sometimes it's 1460, sometimes it has 1452 data points. So we are dealing with a data set in which we can have null values quite a lot. For instance, pool QC has only 7 values that are not null, others are all null. And as you can see, the data set is quite disparate as well. Some are objects, which are basically string or some other data set other than numerical data set. Some are integers and some are float. Float are basically real numbers. These are numbers with decimal points. So currency could be considered float, and real numbers are considered integers. So your mobile number could be considered an integer because it's not going to have a decimal point in that. Right. So I don't want you to get bogged down into the specifics of the code. What I'm trying to tell you is how we are going to do this. So here what we're doing is we are taking all the columns in which our data is greater than or equal to 30%. So any column that contains less than 30% data, which is it has 1460 columns, but only 30 or less percent of the values are present in that, and we are going to drop it. So any column that contains less than 30% of the data, we're not going to consider it at all because it could have negative implications. So we do that. Now what we do is we also delete the ID column from our data set, mainly because ID is just something that is generated by the database in which it was stored, or maybe not by the dataset, but by the people who collected this data. It's not really important for us. It's important for storing the data, but for analysis of the data, ID is just a number that was randomly assigned to a person. It has no significant value. Now we will print the list of columns that were dropped. As you can see, alley, pool QC, fence, and miscellaneous features are the columns that are dropped. ID is the one that we have dropped manually, even though it contained a lot of data. Now we try to do two things here. First thing, we take a look at the sale price, which is a column that we are very interested in because that's the column that we're trying to model our scientific process across. So we describe the data, which is we count the number of columns. As you can see, it contains every bit of data that is available. The mean is 1,80,921 point some value. Standard deviation, minimum value, 25th percentile, 50th percentile, which is here, then 75th percentile or the third quartile, and the maximum value in the column. This is, by the way, this is something that Pandas is doing for us. We didn't have to write functions to loop over the data and figure out the min, max, 25th percentile, and all of that. So it tells us the name of the column, sale price, data type is float, and now what we do is we try to visualize it. So as you can see, the majority of our data lies in this region. Yeah, so here and here. This is what is known as a histogram or distribution plot. Since Seaborn allows us to do it pretty easily, we do it. Don't worry about the code. Stick with us till the end of the presentation and we'll show you how you can learn to write the code. Right now, we're trying to understand the process of exploratory data analysis. So as you can see, even though we have a maximum value of 77,55,000, majority of our values are lying between somewhere around these values, right? Now we take a look at the different data types available in our data set. We have integer, we have O, which stands for object. Object basically means that this is something that's not a number. And we have float. This 64 is basically how many bits are used to represent the data. This means that the data could be of high size. You can, by the way, change this all yourself. So here what we do is we say, okay, give me all the numerical data that we have. This is done mainly because we want to be sure that we are only dealing with numerical data. Dealing with data that is not numeric, firstly we'll have to convert the data into numerical formats and so on and so forth. So we're trying to firstly estimate the task ahead of us. We take the numerical data that contains float 64 and int 64, basically not selecting the object data types. We take a look at the head. As you can see, it has 37 columns. which is a massive drop from what we had earlier. Earlier we had 81 columns, out of which we dropped, I think, 4 or 5 because they had a lot of null values. This one is by far something that we have done only to understand what the data is about. Now we take a look at the distribution of our data using histograms. What we do is we basically create a histogram for all the columns. So again, we didn't have to do it ourselves. These are all 31 columns with histograms, and you can take a look at the data. As you can see, it contains a lot of data. Some columns contain a lot of data that's centered around a particular data point. Others are very separate, such as this one. This only contains values that are 0, so that's fine. And you can take a look at the data and analyze it. We're not going to analyze it right now. This is just for you to understand how to generate these visualizations. Then we take a look at correlations. Correlation basically is a number that allows us to understand how much of our data is how much influence does one column has on a particular column. And we remove the last column because the last row is basically sales, or the last column, sorry, I'll just remove the comment. So the last column is sales, so we don't have to worry about that. From here, we basically just take all the columns with correlation greater than 0.5. We call them golden feature list. Any column that has a higher value than 0.5 on correlation means it has good correlation for our data. We're taking the absolute value, which means we don't care whether it's negative or positive. Correlation ranges from -1 to +1. -1 means if the data in this column decreases, data in the other column which is negatively correlated with it will increase. Positive correlation means data in this column increases, data in other column which is positively correlated with this increase. So we take that and we sort it in ascending values. Now after doing this, we take a look at the correlations. So these are the correlations. The highest correlation we have is overall quality and GR live area, which is around 80 to 70%. Now what we can do is we take a look at all the numerical columns and we generate for the first 5 for all fifth values. What we're trying to do is we're trying to create visualizations to understand how a particular column relates to first 5 columns. So for instance, sales price relating to MS subclass, MS lot range, lot area, and so on. And as you can see, we're doing it for everything, and we're doing it 5 plots at a time. Now that we have done that, here is a bit of a code that's going to be a little difficult to understand. So I'm not going to try and explain it to you. But basically here, what we're trying to do is we're trying to create individual data frames or individual feature data frame as I've named it. Create some temporary data frames based on particular sections, such as we take the column name and the sales price, and then using that data frame we check whether or not the column's value is not equal to 0, and we create or we add it to the data frame. Then we create an all correlations matrix, and then we try to print it. Now we come to the interesting part. So these are all the 11 strongly correlated values that we have, right? For this one, since we had 81 columns and now we have reduced it down to only 11 columns that have really high influence on our sales price column. Now to visualize it, what we have done is we have created something called heat map. Let me just zoom in so that you guys can see. I think I zoomed in a little too much. Yeah, and also you can manipulate the size of this plot by when you're writing code. I'm not going to do it right now, but as you can see that some columns have correlation of 0.4, some have, and this is negative, by the way. As you can see, these are color coded. So any column with light color such as blue or purple are negative. Any columns with light the color such as yellow or green are positive. As you can see, we have 0.83% of correlation with GR living area and fireplaces. And so this allows us to understand what are the particular columns that are highly correlated with each other. Allows us to understand whether or not a column has influence on not just one column but multiple columns, and how does that affect our purposes. With that, we have come to the end of the session and the presentation. Now we'd like to take some time in order to help you understand how you can learn this. We'll guide you through some of the resources and we'll guide you through some of the patterns and practices that allows you to learn these things, allows you to get certified, allows you to get ahead. So let's take a look at that.